Hello everyone, I'm Adinav and I will be walking through question 6 to 10 of SMO Junior 2018. Now let's look at question 6. Question asks that 24 identical containers, each with a capacity of 12 liters. The containers contain some amount of water. If half of the containers are half full, quarter of the containers are quarter full, so on and so forth until 1/12 of the containers are 1/12 full. Find the total amount of water in liters that are in the containers, like in totality. Okay, so for this, the numbers are pretty quite small, 24 and 12, easy to work with, so we can just brute force the values in. So we look at each case, right? Half the containers are half full. So what we can do over here is we can first multiply by half to denote the half full, and then your capacity, which is 12. Yep. And then the number of containers. So the half times 12 refers to your volume, and then your 12 refers to the number of containers. Same thing for everything else. Half times 6 will refer to your volume inside, and 6 refers to the number of such containers which have the stated volume. So we have half times 12 times 12 plus half times 6 times 6, all the way to half times 2 times 2. Then we get 100. Nice. So that's it. The total amount of water is 100 liters. Now let's look at question 7. So here's a question. A quadruple A, B, C, D of positive integers is balanced if the mean, median, and mode of A, B, C, D are equal. How many balanced quadruples A, B, C, D of positive integers are there that satisfy A less than equal to B, less than equal to C, less than equal to D, and A plus B plus C plus D equals to 44? Okay, for this we first have to know the definitions of mean, median, mode. Okay, so hopefully y'all know what it is, or so, but if you don't know, don't worry, so I'll go through that now. So mean is basically the easiest to derive. Basically it's just our normal average. We just take all the four numbers divided by 4. So in this case, right, because we're already given that A plus B plus C plus D equals to 44, and for the mean we have to take A plus B plus C plus D over 4. The mean in this case would be just 11. Yep. And then because they said that if the mean, median, and mode are equal, that means the median is also 11 and the mode is also 11. Okay, so now let's look at median. Okay, median, how it works is for a set with even number of elements, what they do is they look at the middle two elements and then they just take the mean of that. So in this case, because A, B, C, D are arranged in order from lowest to largest, we can just infer that B and C are the middle two. So the median in this case would just be B plus C over 2, which is equal to 11. So if you manipulate it a bit, we can infer that B plus C equals to 22. And because A plus B plus C plus D is equal to 44, A plus D would then equal to 22, which is also then equal to B plus C. So we try to make a lot of connections over here. Yeah. And then lastly, we look at mode. Okay, mode is basically about your popularity. Which number appears the most number of times. That's what mode is defined as. So a mode of A, B, C, D is also 11. So as we've derived in the mean section. So for A, B, C, D to have a mode, okay, it's important to know that not all sets have a mode. They only have a mode if there's like one specific element that repeats the most number of times. Yeah. So to have a mode, only one pair of A, B, C, D can be equal. If there are two pairs of A, B, C, D, it will become bimodal, where two numbers are equally frequent inside the set. So if you have, for example, A and B, A equals to B and C equals to D, you will have two modes because you have two different numbers repeating twice. And or we can either have all four numbers are equal. So in that case, A equals to B equals to C equals to D equals to 11. So you might be wondering if it's possible to have three numbers same. In this case, is not possible, because if you look at this, A plus D equals to B plus C. So let's say A, D, and B are same. If A, D, and B are same, so using the equation a plus d equal to b plus c equal to 22, a can cancel out with b, but d cannot cancel out with c because they are not equal. So this is contradictory, hence it's impossible to have three same numbers. So these are the only two scenarios stated above. Only one pair of ABCD can be equal, or all four numbers are equal. Yeah. So now we can use the inequality a less than equal to b less than equal to c less than equal to d. Okay, in this case, right? Okay, this might be a lot to take in, but yeah, don't worry. We can go through this slowly. So, it is impossible for A to equal to C if you think about it, because if A was to be equal to C, A would also have to be equal to B, and B would also have to be equal to C, and hence three numbers will be same. But we've disproved earlier on that it cannot be possible. Now if A equals to B, C equals to D, and due to A plus D equals to B plus C, so this is possible if A equals to B and C equals to D equals 22. Wait, okay, so we have two cases over here. One is A equals to D. So in that case, A would be equal to B equals to C equal to D, because all of them are less than or equal to. Or we can also have B equal to C and A not equal to D. Okay, what we mean in this place is, okay, this, if you go back, okay, we can, if we remember in the mode section, the first scenario was that we have only one pair of equal. So in this case, one pair of equal will be B equals to C. So in that case, A will not be equal to D, but it still also satisfies A plus D equal to 22 and B plus C equal to 22. So B and C will be 11, and A plus D can be any number so long as they add up to 22 and they satisfy the inequality of A less than B equal less than C less than D. Okay, so we look at this, and then yeah, so what we will have our final solution set. We are not going to list them out all, because usually listing is very inefficient in these kinds of problems, but our general findings is that all our quadruples are in the form t 11, 11, and 22 minus t. So you can see A and D sum up to 22, B and D sum up to 22, and all of these are following the inequality A less than equal to B less than equal to C less than equal to D. So your t, right? So in this case, I've denoted it as x. So it can be clearly seen that all quadruples x x 11, 11, and 22 minus x. To satisfy the inequality, x must be less than equal to 11. Hence, we have 11 such balanced quadruples. Now, this might be a bit confusing, so if you can just rewind back and see wherever you don't understand. Yeah. Look at question 8. On to question 8. In the following diagram, ED is the diameter of the circle. EC, CO, and OD are respective diameters of the three semicircles. If EC equals to 12, CO equals to 4, OD equals to 16, and the area of the shaded region is K pi, what is the value of K? Okay, this is quite PSLE type. So what we can do over here is it's just a simple question on compound area. So if we can realize that there are four semicircles here. We are individually given the diameter of the smaller tree one, but if you want to find the diameter of the larger one, it's just 12 plus 4 plus 6. So usually if you want to find out area, we work with the radius. So what we do over here, to find the radii of EC, CO, OD, and ED, we can just divide each by 2, and then we can get EC 12 divided by 2 equals 6, 4 divided by 2 equals to 2, 16 over 2 equals to 8, and 12 plus 4 plus 16 over 2, which is 32 over 2, which is equals to 16 respectively. So EC equals to 6, CO equals to 2, OD equals to 8, and ED equals to 16. Now, the formula of the area of a circle, of a semicircle, is times pi r square. Okay, I apologize for the formatting. I don't know why it's like this, but it's supposed to be half pi r square because we know that the area of a circle is pi r square, so we just divide it by 2. So because it asks for k pi, we can factor out the pi because we are only asked to find k. So which would just mean we have to find half r square. And calculating the radius of each semicircle we get, so we can just one shot it all together. So once we found all the radii, we can just get k equals to half 6 square plus 2 square plus 8 square plus 16 square. This will eventually give me 180. So yeah, question solved. Okay, now on to question 9. Okay, so for this question, it asks if m squared minus 5m minus 300 equals to 0, find the value of m cubed minus 325m plus 1503. Okay, we there are two ways to approach this, but I will tell the more subtle way first. Okay, you there's a subtle way and a brute force method. So the subtle way is to like just factorize it in a clever way. So firstly we have to okay, not really factorize but rearrange. Apologies for the mistake. So we have to rearrange the following terms. So the main idea over here is that we're trying to add cancelling terms out, and then we're trying to group that to another thing. So you probably get the hang of it as I go through. So m cubed minus 325m plus 1503 equals to m cubed minus 5m squared plus 5m squared. Notice how these two equals to 0. So this does not change the overall value. Minus 300m plus 300m. Also notice that this is equal to 0. So this does not change the overall value. Minus 325m plus 1503. We're using, okay, so let's move on for now. Yep. So if we want to rearrange this, we can get, okay, now we are using the second half of m cubed minus 5m squared plus 5m squared minus 300m plus 300m minus 325m plus 1503. So if you want to rearrange that, we're going to get m cubed minus 5m squared minus 300m plus 5m squared minus 25m plus 1503. And then this will give us, okay, then we can later factorize out the m from the former part of the question, m cubed minus 5m squared minus 300m. We can factorize out the m from it and then add plus 5m squared minus 25m plus 1503. Now substituting inside, right? So if you look back up at the question, m squared minus 5m minus 300 equals 0. Hey, tada! We get m squared minus 5m minus 300 again. So we can just sub that in, m0 plus 5m squared minus 25m plus 1503 equals to 5m squared minus 225m plus 1503. So what we've derived so far is just equal to 5m squared minus 25m plus 1503. So we want again we want to factorize out something, okay? So to make our life easier, yeah. So uh again, what we're trying to do over here is we're trying to add terms, add terms that cancel out each other. So in this case, minus 300 plus 300. So 5m squared minus 5m minus 300 plus 300 plus 1503 equals to 5. Okay, so now we're just cutting off at the minus 300 part, yeah, and then we're pulling out the plus 300 to make it plus 1500. So we're gonna get 5m squared minus 5m minus 300 plus 1500 plus 1503. Look again, we have m squared minus 5m minus 300 equals to 0. Substituting for the final time, what we can get is 5 times 0 plus 1500 plus 1503 equals to 3003, and that is our final answer. So I think this just uh, requires a keen eye and observation to keep adding like like terms, and then looking out for equations, like where to start looking out for the correct substitutions. But if you're probably lazy and you don't want to do all this, that there is another method where you can just factorize this. Okay, this is just a bit lucky because you can factorize this out as m minus 20 m plus 15 equals to 0. So this will be the factorization for this question. So using zero product rule, we can find out that m is equal to 20 or m is equal to negative 15, and then you can just sub in the values into m cubed minus either one of them into m cubed minus 325m plus 1503. Though I think this is a bit tedious because yeah, you have to do a lot of working. So if you are good at mental maths, I would suggest like the brute force method is a bit easier if you're good at working out stuff. But if you like to you do stuff the easier way, but you are very good in observing stuff and picking up stuff, then yeah, I'll suggest you use the method I just spent like 4 minutes explaining. Yep. All right, so I'm at the final question for my part. Question 10. One of the game, three numbers 2, 3, and 5 are written around the circle. In round 2, the sum of every two adjacent numbers with respect to the circle is written between them. The following diagram shows the numbers after rounds 1 and 2. Find the sum of all the numbers written around the circle after round 5. So this is kind of like the Fibonacci sequence, but not really it. So again, this question requires observation. Uh, for now, right, let's just use a more generalized approach, and instead of using 2, 3, and 5, we use A, B, and C to denote them. Okay, so let's focus on the circle on the bottom left corner. So we have A, B, and C. Then in the second round, what we will have is in the middle we have A plus B, B plus C, and A plus C. In the third round are the numbers that will fill up all our black question marks over here. So that's how the game literally works. So if you haven't noticed yet, round 1 our total will be A plus B plus C. Round 2 equals 3 times A plus B plus C, and round 3 equals to 9 times A plus B plus C. Okay, we can notice that the total triples every round, but why? Okay, we will explore a more rigorous proof in the next slide. Okay, so let's take round 3 for an example to illustrate our findings. Yeah. So in round 3, we will have 6 numbers by line A, B, C, D, E, and F. Okay. So the thing is, okay, just a small note over here. B, D, and F were A plus B, B plus C, and C plus A respectively in round 2. So from this, the one of the takeaway we can see from this note is that after each round, all your A plus B, B plus C, you just replace it with a single letter for more convenience and easier to see. Okay, so now let's look at our round 3. Yeah, so we have A, B, C, D, E, and F. So to fill in the gaps, we have A plus B between A and B, and we have F plus A between A and F. uh you and then I've color coded them so you can see all your A's, your B's, your C's, your D's, your E's, and your F's. So if you notice, you can see that there are 3 exactly of each of these letters. One in the original place, like for example for A, we have one right in the original place over here. We have one right over here in the original place, and then you have one in the sum exactly counterclockwise, and then you have one in the exactly clockwise direction, immediately clockwise and immediately counterclockwise. So you have 3 occurrences of each number in each round in the next round's total sum. So that is why you have the total will literally triple. Yep. Explore why the total keeps tripling, we can deduce a pattern. So round 1 equals to 1A plus B plus C, round 2 equals to 3A plus B plus C, round 3 equals to 9A plus B plus C, so on, and round until round 5 where we have 81A plus B plus C, where we keep tripling. In other words, for round n, this is a more general solution. In other words, for round n, the total will be 3 power n minus 1 A plus B plus C. But do remember that we have currently substituted 2, 3, and 5 for a plus b plus c. So our final answer would be 3 times 5, 3 power 5 minus 1 times 10, which is 2 plus 3 plus 5, and that gives us 810. I'll be passing my time on to the other presenters to walk through the other questions. Thank you for listening.